Alright, today we're going to continue our lesson on logarithms, or our chapter on logarithms. Now, section 3 I'm going to divide into two days like we did in chapter 2. Today I wanted just focusing on expanding logs. Tomorrow we will condense logs. I think to do both operations in one day is a little overwhelming. Alright, so the first thing I want you to keep in mind that logarithmic functions are inverses of exponential functions. So think backwards. Okay? So I'm going to go ahead and give you a couple of things. If we have base b to the m power times base b to the n power, what would you do with your exponents? And let me take you even further back. Let's say I have x to the 5th times x to the 7th. You would say I had you would do 5 plus 7, and you would have x to the 12th power. So when you multiply bases, you add exponents. So in general, I would have b to the m plus n exponent. Alright, so now I'm going to show you how it's going to work with logs, because now remember that these are just backwards of your exponential. I need you to think opposite. So if I want to expand this, I'm going to use the idea of this addition of their exponents and say that I can expand this and make it log of base b m plus log base b n. Alright, that's called the product rule. Example 1. Now, logs are one of those where, for those of you who are on the Weebly site and you're seeing the assignment, you might be overwhelmed with the problems, but the more you do, the better you get at learning these skills. So that's why I'm separating these into 2 days and giving you plenty of time to practice. Alright, use the product rule to expand. Log base 6 of 7 times 11. And then the second one I'm going to have you do is log 100x. So to expand this, a multiplication is really going to become, according to the product rule, an addition. So it's going to be log base 6 of 7 plus log base 6 of 11. And that's my answer. So we're expanding it. We're actually making it look worse than it is. And there's a reason why. You'll see when we get to number 2. So the first thing I want to find out is, do you remember what base this log is in? I'm hoping that you remember that if nothing is there, it's base 10. We just don't like to write it. We live in base 10 is what our number system is based on. Alright, so again, do you agree that this is 100 times x? So do you agree that I could write this log of 100 plus log x? Now, can't I write 100 as a base 10? So can I write this as log 10 squared? Now, if you need to put in that little 10 just so that you can remind yourself it's there, there's no problem with that. Just know it's not going to be there in the problems that I give you. Alright, plus log of x. Now here, what happens when I have base 10, 10? You agree from what we've done the past few days that these kind of just all go away, and I'm left with 2 plus the log of x. and that would be my final answer. So now you can see why sometimes expanding logarithms helps us. Okay? Alright, let's try the quotient rule. So I'm going to take you all the way back to beginning Algebra 1 and ask you, what if I had x to the 7th over x to the 5th? And I ask you to simplify it. If you remember, you would do x to the, since you were dividing, you would really subtract 7 minus 5, and you'd get x squared. So in exponential terms, if I have b raised to an m power over b raised to an n power, I can say that's b to the m minus n power. Let's apply it now to logs. So again, I need you to think backwards. Since this is division, we do the opposite when we expand it. It's going to be subtraction. This would be log base b m minus log base b n. Okay? Alright, let's practice the quotient rule. Example 2. Use the quotient rule to expand. Alright, so number 1, log 8, 23 divided by x. Natural log, natural base e to the 5th over 11. So number 1, this time I have a division, which in my mind, working backwards this time, I'm going to subtract. So I'll have log 8, log base 8, 23, minus log base 8 of x. Now, I can't do anything here because I cannot write 23 as 8 to any power. So this is the best I can do. Alright, let's see what you've got here. So I'm going to give you a second to see if you can write out what you think it would look like, and then we'll see if we can do anything to simplify it. So I have natural log of natural base e to the 5th minus the natural log of, and I'm going to make my 1s look like 1s. Natural log of 11. Now, over here, think back. What's the natural log of the natural base? Again, just imagine they're going to cancel each other out, and I'm left with 5 minus the natural log of 11. So again, by expanding, I actually helped. Alright, last rule is called the power rule. I'm going to take you all the way back. Oh, let me label that this is the quotient rule. Go back up to your notes and put this as quotient. Alright, so now I'm going to do the power rule. That's what I like. I like to rule with power. That's your joke for the day. Alright, so all the way back to algebra. X to the 5th squared. So think about this time what you would do with these. So it would be x to the 5th times x to the 5th, which is x to the 10th. So you multiply according to the power rule. So if I apply it now to general exponents, b to the m raised to the n it'd be b to the mn. And so in logs, if you have a log of base b, m raised to a p power, okay, again here the power rule says that you're going to pull the exponent out in front, because remember that's multiplying when you pull it down. Okay, I don't know why I wrote that p so big. How about that? That looks a little bit better, I think. Alright, we're going to practice the power rule, and then we're going to try to put it all together. Alright, example 3. Use the power rule to expand. What if I have log base 6, 3 to the 9th, natural log, a little bit tricky, the cubed root of x, the log of x plus 4 squared. Okay, since I'm raising to a power, that's really multiplying. So let's bring this 9 out in front. Now ask yourself, can you write 3 as 6 to some power? Nope, so that's as simplified as that can get. Now on number 2, I want to go ahead and rewrite it a little bit different for you. Do you agree that if you take the cubed root of a number, that's like raising it to the 1/3 power? So now I can write this as 1/3 natural log of x. Alright, see what you can do on number 3. I'll give you a second. Alright, let's see how you did. This 2 as the exponent is going to be pulled out in front. Now, when you check your work, I want to make sure that you kept the x plus 4 in parentheses. Remember, that's a family, so you can't drop the parentheses. Alright, so far so good. Let's get started on putting it all together. Use the properties of logarithms. And I'm just going to put logs, because you know I'm pretty lazy. To expand each as much as possible. Log base b, in parentheses I have x to the 4th square root of y. Now, what I'm going to do is first take care of, I'm going to do it in little steps. Some people are great at being able to do it all in one fell swoop. I am not one of those people, so I'm going to take you step by step. First thing I'm going to do is realize that x to the 4th is being multiplied by the square root of y. So I know that with logs, multiplication is really going to be reduced to addition. So this is log base b x to the 4th plus log base b square root of y. Now I'm even going to do something a little bit further to help myself. I know that raising taking the square root of something is the same as raising it to the 1/2 power. So I'm going to remind myself that that's what I've done. Okay. Alright, lastly, I now have to get rid of the power. So what do I do to write this in expanded form? I'm going to bring that power out in front. So I have 4 log bx plus 1/2 log by. And that's as good as I can get. Now, I know that right now you might be saying, Ms. Hoffman, this just seems crazy. I'm not quite sure why we're doing all this stuff. To be honest with you, I'm teaching you to take it from its condensed form to its expanded form, because tomorrow I'm going to make you go the other way, because you need to be able to take something like this and put it back into this form to be able to solve it. Okay, so this is something you'll need to be able to use. So that's why we're doing it today. Alright, let's try one more. If I want log base 5 4th root of x, let's raise that x to the 3rd power, over 25y cubed. Alright, again, I'm going to take mine in little baby steps. So my first baby step is to say, what am I going to write the division as? And I'm hoping that you said you're going to write the division as a subtraction problem. Okay? Alright, now this first one I'm going to do a little bit of work with, because this is weird to me. So I'm going to go ahead and try to say, well, if it's to the 4th root, I know that's like taking the 1/4, but I've got the cubed inside. Are you okay if I say that that's really x to the 3/4 power? So this becomes the numerator, that's your denominator. Okay? Alright, so now here I have a power to take care of. I'm going to pull that out in front. 3/4 log 5x minus. Now, interesting here, don't lose sight. What's going on with this 25 and the y squared? Isn't this really multiplication? So I believe I need to do something to it. So how do I expand multiplication? With addition. Alright, we're getting there. I still have this exponent to take care of, and I want to make sure here, this is base 5. Maybe I could write 25 as some base. So let's keep going. 3/4 log 5x minus, I believe 25 is 5 squared, plus, and I'm going to go ahead and take care of that exponent. That exponent is going to come just in front of this term because it's only the y that's cubed. So 3 log 5y. Alright, we're almost there. And again, for some of you this might be painstakingly slow, so feel free to adjust as you need. What happens when I do log base 5 squared? I'm hoping you realize that all this is going to go away, and you're going to be left with 2 plus 3 log 5y. Alright, and the last thing I need you to do is take this minus and distribute it through the parentheses. So my final answer is 3/4 log 5x minus 2 minus 3 log 5y. Okay? Alright, and I think that's where I'll leave off. I have one little thing to show you tomorrow in class, but it won't take us any time at all. So be prepared tomorrow to come to class and work. I have just got one little thing to show you. But I will talk with you guys tomorrow. I hope you have a fantastic night.